Hi dear. So last class we have studied about the images formed in the plane mirror. Okay, right? Today we will learn about the curved mirrors. So most of the places we will use only the curved mirrors. Okay, only few places will be using the plane mirrors. Okay, so the commonly used curved mirror is a spherical mirror. Okay, spherical mirror. What is meant by spherical mirror? It is a part of the reflective spherical surface. Reflective spherical surface. That means, so this is your spherical ball. It's a reflective. All the places are reflective. Okay, it is a spherical ball. What is the definition of spherical mirror? It's a part of the reflective. If light falls here, only this part will reflect, right? So it is this part alone will reflect this light back, right? So it is a spherical mirror is nothing but the part of the reflective surface of the sphere. Okay, it is only a part of this. For example, if light falls here, means only this is your reflective surface, reflective part. Okay. So it is a part of the reflective spherical surface. Okay. Since sphere is it has only curved surface, right? Based on the curvature. That means whether it is curved inwards or curved outwards, we have two types of spherical mirrors. Okay. That is your concave and convex mirror. Based on the curve. Whether it is curved inwards or outwards. Okay. A spherical mirror whose reflecting surface is curved inwards is called concave mirror. So that see this, see actually this is the sphere. So this part is your reflecting part. This is non-reflecting part. Okay. So you are standing here. You can see your face here, right? So if the curve is inwards, ulla. Cave means what? Kuha solvangla. Kuga illa den abindromla. Adukulla pora ulla. So inwards. Cave na inwards abin nyabachkonga. Once you remember this, you can easily remember what is convex mirror. Okay. Curve. If the curve is inwards, then it is called concave mirror. A spherical mirror whose reflecting surface. This is your reflecting surface. See. This is your reflecting surface. Okay, here the light will reflect. A light will fall here and it will be reflected back. Okay, so this is non-reflecting mirror. If the reflecting surface is curved inwards, okay, inwards it is called concave mirror. So once you remember that concave mirror, it is easy to remember convex. Convex means what? It is inwards. So convex means curved outwards. A spherical mirror whose reflecting surface is curved outwards. Outwards, it is called convex mirror. So you are standing here. This is your reflecting surface. Light falls here. It will be reflected back. This is your non-reflecting surface. So it is curved outwards. So it is called convex mirror. Okay. So before we are going to learn how the images will be formed in the curved mirrors, that is spherical mirrors. First we'll learn about some of the terminologies used in the spherical mirror. Okay, so first term is your pole. What is meant by pole? Pole is nothing but the center of the reflecting surface of spherical mirror. Is a point called pole. Okay, that means what? Center of the reflecting surface. So for example, this is, you are standing here. If it is like this, means it is inside. That means it is a concave. Cave. You are going in. Cave kulla poringa in. Okay. This is your reflecting surface. The center of the reflecting surface. So this is your part and this is your center. Center of the reflecting surface is called pole. Okay. So it lies on the surface of the mirror. Mirror leda irukku in the surface. The pole lies on the surface of the mirror. Okay, it is denoted by capital P. Okay, it is denoted by capital P. It is nothing but your pole. It is the center of the reflecting surface of a spherical mirror. It is a point called pole. It lies on the surface of the mirror. It is denoted by capital P. Okay, next. center of curvature. Center of curvatures, it is the center of the sphere of which the mirror is a part. So what is mean by spherical mirror? Spherical mirror means it is a part of the spherical surface, right? This is the spherical surface. It is just only the part. Okay. So center of curvature means this is center of the sphere. So this is called the center of the curvature, right? This is your reflecting part. This is inwards, curved inwards. That means it is a concave mirror. Okay. This is your reflecting part. It is outwards. The curve is outwards, but the sphere, it is part of this sphere. Okay. So which one is the center of the sphere? This is the center of the sphere. This is a convex mirror. So look at this. You are standing here. C lies in front of the mirror. So in front of the mirror, C, that is center of the curvature, lies in front of the mirror. Look at here. C lies behind the mirror. Mirror ku pinnadi irukku. In case of convex mirror. Okay. We are seeing that pole is the part of the mirror. But see, look at this. The center of the curvature is a part of the mirror. It lies on the mirror. No. Center of the curvature is not the part of the mirror. It lies outside the reflecting surface. Okay. But pole lies on the reflecting surface. This is your pole. This is your center of curvature. Okay. Clear? Next term is radius of curvature. Center, you know. Radius, again, it is the radius of the sphere of which the mirror is a part. It is denoted by R. That means what? This is your spherical mirror. It is actually a part of a sphere. So radius of curvature is nothing but the radius of this sphere. This is your radius. Radius of curvature. Okay. Here, this is your radius of curvature. Clear on this? It is the radius of the sphere. Okay. This is the radius of the sphere of which the mirror is a part. In the mirror edoda part la irukku, in the sphere oda part la irukku. In the sphere oda radius, the radius of curvature. Okay. Next one is your principal axis. Principal axis. It is an imaginary line. Okay. It is a principal axis is an imaginary line. Okay. It is a straight line which passes through the pole and the center of the curvature of the sphere. That means what? This is your sphere. This is your reflecting surface. So this is called spherical. This is called spherical mirror. This is your pole. P is here. If this is outwards means center will lies behind the mirror. This is C. The straight line which passes through the pole and the center of the curvature. A straight line which passes through the pole and the center of the curvature. It goes like this. It goes endlessly in this direction, endlessly in this direction. So the straight line, imaginary straight line which passes through the pole and the center of the curvature is called principal axis. Okay. Next one. Principal focus. This is very important. Okay. Principal focus. Focus at this point. Okay. Or point la focus pannunga appdinu solli. It is a point on the principal axis. You know the principal axis. Where is the principal axis lies? It passes through the center of the pole, center of the mirror, center of the curvature and the pole. Right? It passes. This is your principal axis. It is a point on the principal axis. Principal focus means in the line la da in the focus point irukkudu. Where the rays of light incident on the mirror. The rays of light incident on the mirror and it is reflected back, right? Rays of light incident on the mirror parallel to the principal axis converges or appears to converge. என்ன பண்ணுவோம் எப்பவுமே நம்ம என்ன reflection பார்த்திருக்கோம். Reflection of lights na instant eye it will be reflected back. Okay, instant eye it will be reflected back. This is your instant ray, this is your reflected ray, right? So all these rays are parallel to the principal axis. It is parallel to the principal axis and reflected back. it converges at all the rays converges at a point. That point is called principal focus. Okay, this is your reflecting surface is curved inward. This is a concave mirror, right? And it is converging here. Okay, it is converging here. So we have written converges. Okay, mirror parallel to the principal axis converges. Okay, or appears to converge. Okay, here it is converged. So why we have to use the appear to converge means in case of convex mirror. In case of convex mirror, so look at this. So this is your incident rays, same parallel to the principal axis. It is reflected back, bounce back. This is a reflected ray. Okay, it is not converging, it is actually diverging. See, look at this, it is diverging. And we assume that it appears to converge here. It appears to converge here. That's why I mentioned in the dotted line. It is not actually converging. It is actually diverging rays. Okay. It appears to converge here. This point is called principal focus. Clear? This here, it is a concave mirror. It converged. Okay. In the convex mirror, it appears to converge. It is actually not converging. Right? It appeared to converge. Since here it converged, it is called, this concave mirror is otherwise called converging mirror. Okay. Here the rays are diverted. So this convex mirror is called diverging mirror. Clear on this? I'll repeat once again. Principal focus always lies in the principal axis. Okay. In the principal axis la dhaan irukum. Okay. See, look at this. This is a principal axis. Principal axis means what? The line which passes through the center of the curvature and the pole. Line which passes through the center of the curvature and the pole. So, what is principal focus? A point that lies on the principal axis. Okay. How it will, how this point has been formed? Once the light rays incident on the surface, it will be reflected back. Okay. It will be reflected back and it converges at a point. That is your principal focus in case of concave mirror. But in case of convex mirror, it is diverging, right? It is diverging. So, it appears to converge here. Okay, it will never meet. It will never meet. It will be diverging. But it appears to converge here. Okay, so it is a diverging mirror in case of convex mirror. Next one is what? Focal length. Focal length. This is denoted by small f. This is actually small f. The distance between the pole and the principal focus of a spherical mirror is called focal length. It is denoted by a small f. Okay. The distance between the pole and the principal axis. See, this is the distance between the pole and the principal focus. So this distance, actually it is called focal length. Okay. This distance between the pole and the principal focus is called focal length, small f. Okay. Clear on this? So I'll repeat, focal length is the distance between the pole and the principal focus of a spherical mirror. Right. And the last part of this spherical mirror is a aperture. Aperture is nothing but the reflecting surface of the spherical mirror. Reflecting surface means what? This is a sphere and this is a reflecting surface. This part, this is known as, only from in this part the light will be incident, right? So this is your aperture. Okay, this diameter of this reflecting surface. The reflecting surface is, if you look from here, it will be curved. If you look from in the sideways, it will look like this. In the front, it will be look like this, right? So this is your diameter, right? This is nothing but your aperture. This length, this distance. This is your aperture. Okay, aperture. So we can say that the aperture is nothing but the diameter of the reflecting surface of spherical mirror. So this part, you know, diameter of this part is called its aperture. If the surface, we will say this aperture, diameter is its aperture if the surface has a circular outline. See, it is only a curve. So this is a sphere. Only this is a reflecting surface, means your aperture is like this. Okay. If the reflecting surface is large, for example, this much big, means then what is the aperture? This is your aperture, right? This is your aperture. This is nothing but your diameter of the sphere, right? Okay. Usually we will not take this bigger aperture. Why? We will usually take a smaller aperture whose aperture is much smaller than the radius of the curvature. Why? Means if the light strike on the reflecting surface, it will try to reflect back. Okay, once it instant on the surface, it will try to reflect back. In case of this is your convex mirror, right? It appears to converge at some point, right? It appears to converge at some point. If you look at this, you will not get the focal point. It will not converge at a single point. You know that this is your pole and this is your center of the curvature. The principal axis is there. Your principal focus point lies on the principal axis, right? It appears to converge, right? But in case of a bigger aperture, the you will not get a single focal point. Okay, it will not converge at a single point. Okay, you will get only the blur image. Okay, so we'll always prefer the smaller aperture. Okay, that should be even smaller than the radius of the curvature. Okay, then it will easily converge. See, if you draw this concave mirror, if it is like this, if the aperture is big, the light falls on this and it will be reflected back, right? You will not get the single focal point. So it will not be focused in a single point. Okay, so you will get a blur image. Okay, so here in this study we will consider only the smaller aperture. Okay, in case of the circular outline, surface is big. If the aperture is of a circular outline like this, your diameter, this is your aperture. Okay, this is your aperture. This is, if the aperture is small like this, see, this is your reflecting part, this is your reflecting part, then this is your aperture. Okay, fine. So we use spherical mirror whose aperture is much smaller than its radius of curvature for study purpose. Okay, next we have one relationship between the radius of curvature and focal length. Okay, what is that? Radius is equals to 2 times of its focal length. Focal length is the distance between the focus point and the pole, right? So this is your sphere, this is the radius, this is the center of the curvature. For example, this is your reflecting surface. That means this is the pole and this is your focus point, principal focus, and this R, radius is this R is equals to 2f. When this R is equals to 2f, then this focal point lies in the center of the middle of the center of the curvature and the pole, right? It shows that principal focus of a spherical mirror lies midway between the pole and the center of the curvature. Okay. So what is the relationship between radius of curvature and focal length? R equals to 2f. Small f indicates the focal length. Okay. Thank you.